Assalamu alaikum. Dear students, we are discussing the object model of the ODMG 3.0 in the course Object-Oriented Database Management Systems. We have discussed different aspects of the object model, and today we are starting our discussion from the concurrency control part of the object model. We have already discussed what is concurrent access, and we have already studied in the basic course of databases that the concurrent access is very much required or desirable in a database environment, in any database environment. And we have discussed that today we cannot even think about an environment where database is not providing or supporting the concurrent access. But concurrent access basically brings with it certain problems. If the concurrent access is not properly controlled, then database may encounter certain problems, and those problems are only due to the concurrent access. So if the concurrent access is not properly controlled, database may encounter those problems and it may become inconsistent. And this is a very basic principle of the database, is that you can never compromise the consistency of the database. This is the most prime or top most priority while maintaining or running or having a database system. And I told you that you can compromise perhaps any quality of the database, any feature of the database, but you cannot compromise on the consistency of the database. Because when you compromise on the other facilities or the features of the database, like you say efficiency, speed, or let's say even an interface, a beautiful interface, or a very user-friendly environment, all that are so much required nowadays that they have become sort of an essential part of working on a database. But still, the most important thing is consistency, because having an inconsistency in the database may be disastrous. So, in the nutshell, concurrent access is very much desirable, or is sort of a part and parcel of the database environment, but you have to maintain the consistency. This is the bottom line. So, there are different problems that we may encounter if we do not control the concurrent access properly. And those problems you might already know are the lost update problem, and uncommitted update problem, and thirdly is inconsistent analysis. These are the three problems that we have discussed in the previous course, and we know that if we do not control the concurrency properly, then these three problems may be encountered in a database environment, and these problems may transform the database into an inconsistent state. So, as far as the consistency of the transaction is concerned, so again we are using another term here, the transaction. We already know that the transaction is the basic unit for the database execution, you can say, and also for the concurrency control. So, as far as the transaction is concerned, or the consistency as a result of the transaction is concerned, the consistency of the transaction, or you can say that the transaction maintains the consistency of the database. This is the responsibility of, or the job of, the transaction itself, or you can say the person who is writing, who is developing that transaction. इसका मतलब ये है कि the developer, the designer, he is basically responsible for the consistency of the transaction. इसका मतलब ये है कि a transaction does not cause inconsistency. That is the responsibility of the developer or the person who has developed, who has written that transaction. So transaction within the consistency within the transaction is the responsibility of the developer, but the consistency due to the concurrent execution of the transaction, this is the job of the concurrency controller or the concurrency controller subsystem of the DBMS. And in this case, when we are discussing the object-oriented database management system, in this case, this is the job of the ODMS, Object Data Management System. And this is the term that has been used by the ODMG standard or book. So, maintaining the consistency due to the concurrent execution of the transactions, this is the responsibility of the concurrency control subsystem of the ODMS. And we already have discussed that these are the three problems that may cause due to the user accessing the database at the same time. So it means this is the scenario, this is the situation that has to be dealt by the concurrency controller subsystem of the ODMS. There are two main techniques that are used for the concurrency control, and one of them is locking based and the other one is timestamp based. The DBMS is in general use any one of them or sometimes both of them to control the consistency of the database, obviously. But in the object model of the ODMG, the locking based technique has been adopted. So the ODMG 3.0 standard supports the locking based mechanism to control the concurrent access of the database, of the object database. So as the name suggests, that the locking based technique is based on the concept of lock. And a very well known mechanism that is generally adopted in the DBMS is the two-phase locking protocol. And we can just briefly reiterate that the element has to be locked before a transaction can apply or can perform any operation on that object, on that element. It means when a transaction wants to perform any operation on a data item or an element, and in this case on an object, then first the transaction has to acquire the lock. Now there are different types of lock. For example, the two major types are the read lock and the write lock. It means the nature of operation that a transaction wants to perform on an element. Before performing that operation, the transaction has to acquire that type of lock. It means that if the transaction wants to perform the read operation, then it has to have the read lock on that data item. And if a transaction obviously wants to perform a write operation on an element or on a data item or an object, then that transaction has to have the write lock on that data item. When we talk about this locking mechanism or when we talk about the concurrency control mechanism, we know that two transactions, because now we are discussing a scenario, a situation when multiple users are accessing the database at the same time. So we know that when two different transactions, they are performing any operation on two different data items, then there is no problem at all as far as the concurrent access is concerned. Or we can say that the three problems that we have already discussed that we may encounter during the concurrent access of the database. So those three problems will not occur if two transactions, and when we say two transactions, it can mean many transactions, let's say tens and twenties and hundreds of transactions. They are doing any operation. Any means they may write, they may read, or they may upgrade something. So upgradation is also basically a type of writing. So we can say as many as the DBMS supports or as there are users, so many transactions working at the same time, running at the same time, and performing any operation, but all of them on different data items. In that case, there is no problem at all. So means concurrency control mechanism, or it doesn't have to bother in that situation, because there is no problem going to occur out of those three problems. Okay, this is one scenario. Second is that multiple transactions, and let's say we to narrow down the scope, we say two transactions accessing the same data item, but both of them are reading that item, or let's say the object. Again, in this case, there is no problem at all. Or we can say, when we say no problem at all, then basically we are talking about the problems of the concurrent access. So we say that if two transactions are reading the same data item, then we won't face those three problems of the concurrency or the concurrent access. Now, the situation that is problematic, where those three problems can occur, is that two transactions accessing the same data item, and any one of them or both of them are writing that data item. So this is the situation that may cause the problem. This is the situation when those three problems of the concurrent access that we have discussed, they may occur. And when any of those problems occurs, it leads the database into an inconsistent state. And that is the thing that you never ever want. तो जो कंकरेंसी कंट्रोल का मैकेनिज्म है, उसकी जो बेसिक रिस्पॉन्सिबिलिटी है वो यही है कि these three problems of the concurrent access, they should not occur. तो जाहिर है कि your concurrency controller is basically always monitoring the type of access that the transactions are applying on different data items. And then if a transaction wants to perform any operation on a data item, it has to apply for that type of lock. Now, if the data item on which the lock has been applied by a transaction is free, free means that no other transaction has got any type of lock on that data item, it means that data item is free or that is available. So the lock will be granted straight away. This is the problem. Second situation is that a transaction applies a lock on a data item, and that data item is already locked by some other transaction. So in this case, the applying transaction will go into the wait state. Wait state means that it will stop executing. Now, the transaction that has applied for a lock on a data item, and that item was already locked. So this transaction will go into the wait state. It will go into the wait state till the other transaction that has got the lock on that desired data item is completed. When that transaction is completed, all the locks held by that transaction, all the locks on all the data items that were held by that transaction, they will be released. And releasing the locks mean that those data items will become free. When the data item required by this transaction that was in the wait state gets free, then the concurrency controller, or we can call it the scheduler, it assigns the lock on that data item to this transaction that was waiting. So obviously this gets the desired lock on that data item, and now it starts executing. So it goes on, and again the process goes on. For example, again it requires the lock on another data item. Again this process will be repeated. The scheduler will check whether that data item is free or not. If it is free, lock will be granted, and if it is not free, then it will have to wait, and things go on till the transaction reaches its end. So this is the very basic philosophy that you apply for the lock. If it is free, you get the lock. Otherwise, you go into the wait state. In order to increase the concurrency, because increasing concurrency means the fast execution. Because when you put a transaction into wait state, it means that transaction is not executing. It means that transaction is consuming time. It means the user or the application that has initiated that transaction has to wait. और इसके एग्जांपल यही है कि यानी आप अगर जो बहुत कॉमन एग्जांपल है जिससे कि ऑलमोस्ट हम सब लोग जिससे फेमिलियर है वो ये है कि हम जब अपना एटीएम कार्ड यूज करते हैं ऑन एनी एटीएम मशीन. So obviously when we go into the ATM, we prefer that our transaction is completed and completed successfully as soon as possible. So if we put the card in and then the machine goes to sleep, and after let's say 2 or 3 minutes it says, okay, now enter your PIN, for example, and then again when you enter the PIN it goes into another sleep, and then you are again waiting. Obviously this situation is not very much liked or appreciated by user. So same is the case in any case, any situation where a user is using the database and he initiates a transaction or any request, and obviously every user will prefer that it gets the reply as soon as possible and successfully. So this is the basic model that we say that transaction either gets the lock or either it goes into wait state. So we were discussing that in order to increase the concurrency level, there are two things that the concurrency control mechanism adopts. One thing is the compatibility of the locks. So the basic line, a basic theme that if the object is free or available, then you assign the lock, or and if it is not free or not available, then you go into the wait state. To improve the situation and still maintaining the consistency of the database, the concurrency controller adopts a strategy that is called the compatibility of locks. It means that if some locks can be granted to multiple transactions on the same data item at the same time, then obviously the result will be improved speed or efficiency or response time for different transactions. Why? Because if you can assign some lock to multiple transactions at the same time on the same data item, we're talking about the same data item, because we have already discussed that if multiple transactions are working on different data items, this is not a problem at all. So let's say there are hundreds of users. Let's say if we discuss about the ATM situation, if let's say we say that a bank has, let's say, 300 ATM in Pakistan, and all 300 of them, let's say, they are populated, means there are users there, there are customers there, and all 300 of them, they use the ATM at the same time. Now considering that there are different people with different accounts, none of them is using the same account, and considering all the infrastructure like network and system is working properly, then all those 300 people can perform their transaction at the same time without any problem, without any delay. Why? Because they are accessing different data items. And although if all of them are withdrawing the cash, it means the write operation is being performed on the database. But because all of them are writing different data items, it means in this case there will be no problem at all, and all of them will be able to perform the required transaction and without any delay or without getting into the wait state. So it means that if different transactions are accessing different data items, then there is no problem at all. Now we were discussing the compatibility of the locks. So we can say that if multiple transactions can be assigned the lock on the same data item at the same time, then that will definitely increase the level of concurrency. Why? Because let's say two different transactions apply the lock at the same data item, and if neither of them goes into the wait state, why? Because they can be assigned the lock at the same time, then that would be good. Obviously, why? Because neither of them has to go into the wait state. It means it improves the response time, and that will very much be appreciated or liked by the user, obviously. But the bottom line is that we cannot compromise the consistency. It means that in order to assign multiple locks to different transactions at the same time, we have to see whether the locks being assigned simultaneously, are they going to cause any problem or not? Because again, consistency cannot be compromised. So it means there comes the concept of the compatibility of the locks. So the basic rule regarding the compatibility of the locks is that if two transactions and even multiple transactions are applying the read lock on the same data item at the same time, then they can be assigned that lock. It means that the read lock applied by different transactions at the same data item at the same time is compatible to each other. So they can be assigned that lock. So it means that if hundreds of transactions want to read a data item, just read a data item, that lock can be granted to all those transactions. It means that when you are reading something, so many transactions can read that data item at the same time. And examples is your website, for example. Let's say we consider the website of any, let's say, newspaper. So there could be hundreds and thousands of users trying to read a newspaper through internet at the same time, and all of them are able to read that newspaper. Why? Because all of them are just reading that site or that newspaper. See, this is the difference between the concurrent access and the serial access, or the serial access. Because if it was the serial access or single user access at one time, it means that let's say if we consider the newspaper example, so any newspaper, it is published online, and let's say hundreds or tens or thousands of users are trying to read that paper, and if it is available to one person at one time, so it means one person is reading the newspaper and rest of them, they are waiting. No use. So this is the basic concept that is being applied there, that because this is the situation when none of the users who are accessing the website of the newspaper, none of them can write there, none of them can update there. So it means all of them, they are just going to read that paper. So this is it means that all those transactions that are working from, let's say, throughout the world, from all over the world, they are trying to access that newspaper, but all of them, they are just going to read that newspaper. It means all of them, they are applying for the read lock, and because read locks are compatible with each other, so thousands of people can read the paper at the same time, because all transactions are requesting for the read lock, and read lock are compatible with each other. But let's say if at the same time the administrator or the people who are managing that site or that newspaper, if they want to update, if they want to make some change to, let's say, to the news, if they want to add some news on their website, so for that time when the administrator is in the process of updating that site, or they're trying to add a new, let's say, news there, it means at that time they will apply for the write lock. So at that time, none of the user will be able to access that site, to access that paper. Why? Because at this time a write lock has been requested, and write lock is not compatible with any lock. So compatibility says that if any transaction has got the read lock and a new transaction applies for the write lock, then the write lock will not be granted. So if we talk about the newspaper example, it means that, let's say, thousands of people, they are reading the paper, and let's say at some time the administrator wants to add some news on their website. What will happen? They will have to first break all those transactions, they will have to make that newspaper unavailable for all of them, because now they want to update that site. When they want to update that site, for some time it will not be available to any user. Why? Because this transaction is now applying for the write lock, and the write lock is not compatible with neither the read lock or the write lock. So this is basically the compatibility of the locks that is basically helpful to increase the level of concurrency and without compromising the consistency of the database, because that is the bottom line. So we were saying that the concurrency controller applies two mechanisms to increase the concurrency level of the database. One is this compatibility of locks concept, that it sees that what locks can be granted at the same time, so to avoid the transaction to go into the wait state unnecessarily. And the second mechanism and second technique that is adopted by the concurrency controller is to decide the granularity of the lock. Granularity means ke at what level the locking is applied on the database, because there is a sort of hierarchy of elements or of the data items in the database, and that obviously when there is a hierarchy, it means there are different levels. So this hierarchy is that at the topmost level is the database, the entire database. Let's say if you talk about an object-oriented database system, then let's say there are 50 classes. So it means that all those 50 classes is the database. So at the top level is the database. Then at the next level is different areas, because when the DBMS stores the database or the files in the database, it arranges them into different areas. So it means that, say, if we're talking about a database that has got 50 classes of files, so maybe it is arranged into 6 areas. Now, there are different reasons or different approaches to manage or to decide about those areas, maybe due to efficiency of access or due to their closeness and something. On different basis, the DBMS desires the different areas in which the DBMS places those files, basically where the data is stored. So on the topmost level is the database, and the next level is the files or areas, the areas. And the next level is the file, an individual file that contains the data. Then after the file is you can say, the records or the objects. And then the next level is the individual items, that could be the attributes. Yes, the attributes. So this is the hierarchy of the data elements, where in which the data elements are stored within a database. The granularity means that at what level the logs are being managed by the DBMS. If we move higher in this hierarchy, means that if we manage the logs at the higher levels, let's say at the file level or at the area level, or let's say on the entire database level, that will make the concurrency control job much easier. That means कि concurrency control को control करना will become much easy if we raise the granularity or the level of locking. But that will decrease the concurrency level. यानी इसका मतलब ये हुआ कि देखिए ना, अगर if a transaction applies for a lock, let's say a transaction wants to add an object into a database, and to make the life easy for itself, the DBMS applies the lock on the entire database. Very simple. In this case, the job of the concurrency controller will be very easy. One transaction applies the lock, you lock the entire database, you don't need to do much work. When that transaction is finished, you release the lock and give the access to other transactions. So this is the easy job, easy life, but with very limited concurrency. And again, that will not be appreciated by the users, obviously. See, you're designing your database, you're writing your application, you are developing all the system basically for the users, for the convenience, for the ease of users. So in this case, your life is easy. I mean, I'm talking about, let's say, the developer, designer, or let's say the DBMS. Life on that end is easy, but with very little or very limited concurrency. So it means that life for the users is a bit difficult. Why? Because they have to wait. So higher the concurrency level, easy the job, but less concurrency. And as you move down the hierarchy, I mean, if you lower the granularity level, you come to the attribute level, for example. In that case, the concurrency will increase a lot. But the job of the concurrency controller becomes very difficult. Why? Because it has to take care of many things. It will have to apply many locks. It will have to manage many locks at the same time. So this is the second technique. This is the second strategy that is used by any DBMS to manage the granularity level. So as I told you, if you go higher in the granularity of the locks, then you will reduce the concurrency. But if you decrease it, if you move down this hierarchy, and let's say if you reach to the leaves of this tree where you find the attributes, then there is maximum concurrency. But managing it will be very difficult. So when we say that the granularity comes to the leaf level in this hierarchy, it means that the locks are being applied on the individual attributes. So it may happen that two different transactions writing two different attributes of the same object. This is really the height of the concurrency, that let's say we say a particular object. Let's say if we talk about employee. If we have an employee object, and if we adopt the granularity level up to the attribute level, what can be the situation is that two different transactions, one of them, let's say, writing or changing or updating, let's say, the salary of that employee, and at the same time another transaction will be writing, let's say, will be changing the address of the same employee. Well, this is the highest level of concurrency, and I mean, managing it is very difficult. Why? Because maintaining locks up to the attribute level, and when you say attribute level, it means you are allowing two different transactions to update or to change the data in the same object, in the same record. So this is basically the height of concurrency. So anyways, this was the second strategy that, as I was discussing, that is adopted by the DBMSs to increase the concurrency level. One is the locking compatibility or lock compatibility, where they assign locks to different transactions to the same data item. And second is the granularity level, where they can adjust the level of locking, so that that determines the level of concurrency that the DBMS offers. So these are two strategies that I told you that the DBMS or any even ODMS adopts. Next thing that is encountered in a locking based concurrency control mechanism is the deadlock. Deadlock is a situation when two or more transactions, they are in the wait state, and they are waiting for the data items to be released that are held by each other. So what happens is that, let's say if we consider this scenario at the two transactions level, then we can say that, let's say a transaction A is executing, and at the same time transaction B is executing. Now let's say transaction A needs a lock, let's say read lock, on a data item X. It applies for the lock on the data item X, but that is held by the transaction B that is currently also executing. So this the item is locked by the transaction B, and the type of lock that the transaction A has applied is not compatible with that lock. So transaction A goes into the wait state. It stops now. B is executing. After some time, B needs a lock on, let's say, data item Y. It applies for the lock on the data item Y, but the data item Y has been locked by the transaction A that is now in the wait state and stopped. So transaction B applies for the lock on the data item Y, and the nature of lock is such that it is not compatible with the lock already acquired by the transaction A. So again, B also goes into the wait state. So both of them now are in the wait state, and both of them are waiting for the locks to be released on the data item that are held by the other. So as both of them are waiting, both of them are not executing, it means that when they will not execute, it means they will not be completed. When they will not be completed, the locks held by these transactions will not be released. When they're not released, other is not going to get that lock. It means it will never execute. So it means in this situation, both of them will be waiting. And this is a deadlock situation. The type of operations that are performed within the transactions, their nature is such that the concurrency controller or the scheduler cannot predict beforehand that a deadlock situation is going to occur. This cannot be determined beforehand. Why? Because you cannot determine before the execution of the transaction that which data items will be required by a particular transaction and what types of locks will be required on those data items by a transaction. So in most of the cases, this is not possible beforehand to judge that a deadlock is going to happen, is going to occur, so that we prevent that situation to occur or prevent that deadlock to occur. This is not possible. So it means when you are adopting the locking based mechanism for the concurrency control, you will face the deadlock situation. Well, in different situations, you may encounter more or less number of deadlocks, but anyway, you cannot totally avoid facing the deadlock. It means any locking based mechanism, any locking based concurrency control environment, you will face the deadlock. And once you face the deadlock, so I mean any of the transactions, rather if we are talking about the two transactions, so neither of them is going to be completed. So I mean they are waiting and waiting, and we can visualize this situation in a situation when, let's say, let's say you have a bank account, and let's say you applied for 2 ATMs for your account, and one you have given, let's say, to your wife. If you are not married, then to your friend, obviously. So just by chance, both of you and your friend or your wife, you go, well, your husband too, if you are a female, you go to different ATMs and you insert your cards into the ATM at the same time, and you want to perform, let's say you want to withdraw some money. So you are applying for the obviously right operation. So this is a situation when because you are withdrawing the money from the same account, it means both of these transactions are going to write to that data item, to that record. So in this case, because both of them will apply for the write lock at the same data item, they will go to the wait state. So what will happen? So both of you are standing in front of ATM because you are the deadlock, and ATM, your application at the ATM is waiting for the lock to be released. Because it is happening at the both ATMs, that lock will never be released, and you are standing there. So you can have a chat with your friend on the mobile, then you can have even a drink over there. You can do anything, but because that deadlock is there and it is never going to be released, because both of them are waiting for each other, and because none of them can move further, so it is never going to be finished. So both of you do anything, but you stay there. Anyways, but there are different mechanisms that adopt to avoid this situation. But I'm telling you the basic fact, the basic situation, which is if not dealt, then you are standing, and it will not move. This is a situation when two transactions go into a deadlock, and this deadlock situation, it may involve not only two transactions, but it may involve multiple transactions. Let's say like 10 transactions or even more than that. And this is a situation that when we say that transaction A applies for a lock held by B, goes to wait state, then B applies for a lock held by the transaction C, B goes into wait state, C applies for a lock held by the transaction D, goes into wait state, then D applies for a lock held by the transaction E, goes into the wait state. It can go on and on. And let's say a transaction X, you have moved from transaction A to transaction X, let's say 25 transactions. And X has applied for a lock, let's say that is held by transaction A. So you go back to transaction A, and because transaction A is waiting for B, it is already in wait state. So what happens is now, again, this is a deadlock. So as I told you that this is not possible for the DBMS or the concurrency controller to prevent the deadlock to occur in any locking based mechanism. So next best solution is to detect that a deadlock has occurred. And after detecting that deadlock has occurred, you have to resolve that. So this is the strategy that is generally adopted by the DBMSs to detect the deadlock and to resolve it. So for this purpose, the strategy that is generally used is called the wait for graph. So whenever a transaction goes into the wait state, the DBMS or the concurrency controller manages or establishes a wait for graph. Wait for graph is obviously a graph that consists of nodes and links between them. So when a transaction A goes into the wait state for a data item that is held by the transaction B, so a graph is created where there are two nodes and a link is created from transaction A to transaction B. Now, if transaction B goes into the wait state due to some other transaction, let's say transaction C, then again this graph is appended in this form, that a node is created for transaction C and a link goes from transaction B to transaction C. So it can go on and on. But when there is a cycle, there is a loop. Cycle means that you move from one node and traversing these links, you come back to that node by following or by traversing those links. You come back to that node, that forms a cycle or a loop. So whenever there is a cycle or loop in the wait for graph, that reflects a deadlock situation. So as I was telling you that the DBMS or the concurrency controller keeps monitoring the wait for graphs because it is creating the wait for graphs anyway. But at the same time, it keeps traversing them. After a certain time period, it traverses those wait for graph. And if anywhere it finds a loop or a cycle, it immediately knows that here is a deadlock. And the solution to resolve this deadlock is to break this cycle or loop. And the mechanism that is adopted is that to forcefully break or kill or finish a transaction. Now, how that transaction is selected, that is another issue or another strategy of the story. But the basic idea is that the concurrency controller selects a transaction involved in that loop based on any policy, and it breaks that transaction. Breaking a transaction means that transaction no more exists, is finished. So what happens is then that all the locks acquired or held by that transaction are released. When they are released, they are given to the transaction that was waiting for those data items. So that transaction moves on. When that transaction finishes, it releases the locks, and then the locks held by that transaction are given to other transaction, and this way all that wave forward graph is resolved and the transaction goes on. And the transaction that was broken, that was aborted, that is initiated again. So the process goes on this way. So this is another issue that we generally encounter in the locking based mechanisms. So this was an overview of the locking based mechanism in general. So the object model of the ODMG 3.0 follows the locking based mechanism for the concurrency control. So it means that the objects are shared among different transactions, and as we have discussed that before allocating or before giving a right to perform any operation on an object, تو جو آپ کا کنکرنسی کنٹرولر ہے وہ اس آبجیکٹ پہ لاک اپلائی کرتا ہے, اور لاک جو ہے وہ ظاہر ہے کہ اس کو رائٹ دیتے ہیں کہ وہ کیا اس پہ ریڈ کر سکتا ہے یا رائٹ کر سکتا ہے. اور جب وہ ریڈ کرنا چاہتا ہے اور ریڈ لاک کے لیے اپلائی کرتا ہے تو اس لاک کو ہم کہتے ہیں شیئرڈ لاک, کیونکہ یہ لاک جو ہے وہ شیئر کیا جا سکتا ہے باقی ٹرانزیکشن کے ساتھ جو کہ صرف اس کو ریڈ کرنا چاہتی ہیں. اور اگر فرض کیجئے کہ کوئی ٹرانزیکشن جو ہے وہ کسی ڈیٹا آئٹم کو رائٹ کرنا چاہتی ہے تو اس کے لیے اس کو رائٹ لاک لینا پڑے گا, جس کو کہ وہ کہتے ہیں ایکسکلوسیو لاک, اس لیے کہ یہ لاک اس طرح کا ہے کہ جو کہ باقیوں کے ساتھ شیئر نہیں ہو سکتا, تو وہ ایکسکلوسیولی اسی ٹرانزیکشن کو دیا جائے گا. تو اس وقت جب کہ وہ ٹرانزیکشن اس کو رائٹ کر رہی ہے تب تک اس کو یعنی لاکس نہیں ملیں گے. اور اس میں بلکہ جو ہم نے پہلے ذکر کیا تھا کہ اس میں جو 2 phase کمٹ جو اسٹریٹجی ہے وہ اڈاپٹ ہوتی ہے, اور اس کا بیسک آئیڈیا یہی ہے کہ آپ کے جو لاکس گرانٹ کیے جاتے ہیں وہ 2 phases میں گرانٹ کیے جاتے ہیں. یعنی آپ کا جو شیڈیولر ہے, جو کنکرنسی کنٹرولر ہے, وہ جب ایک ٹرانزیکشن کو لاک ایلوکیٹ کرتا ہے, اسائن کرتا ہے, تو وہ 2 phases میں کرتا ہے. ایک کو آپ کہتے ہیں گروئنگ فیز, یہ وہ فیز ہے کہ جس میں کہ لاکس جو ہے کسی ٹرانزیکشن کو اسائن کیے جاتے ہیں. تو جب تک یہ ٹرانزیکشن ایکسیکیوٹ ہو رہی ہے تب تک اس کو لاک ملتے رہیں گے, اور جب وہ ٹرانزیکشن جو ہے وہ تمام لاکس ایکوائر کر لیتی ہے تو اس کے بعد لاکس جو وہ ریلیز ہونا شروع ہوتے ہیں. اور اس وقت ہم یہ کہتے ہیں کہ یہ ٹرانزیکشن جو ہے وہ شرنکنگ فیز میں آ گئی ہے, یعنی تب وہ لاک جو ہے وہ ریلیز کرنا شروع کر دیتی ہے. اور 2 phase کمٹ پروٹوکول کی بیسک فلسفی یہی ہے کہ جب ٹرانزیکشنز کو لاک مل رہے ہیں تو دیٹ ٹرانزیکشن از ان دا گروئنگ فیز, اور جب وہ ٹرانزیکشن لاک ریلیز کرنا شروع کرتی ہے دیٹ انٹرز انٹو دا شرنکنگ فیز. ونس اے ٹرانزیکشن گیٹس انٹو دا شرنکنگ فیز, اس کے بعد اس ٹرانزیکشن کو لاکس جو ہے وہ نہیں مل سکتے. اب ظاہر ہے کہ جیسے میں پہلے کہہ چکا ہوں کہ پہلے سے ڈٹرمن کرنا کہ کوئی ٹرانزیکشن جو ہے اس کو کتنے لاکس چاہیے یا کس ڈیٹا آئٹم پہ کس طرح کا لاک چاہیے, یہ پہلے سے ڈٹرمن کرنا پاسبل نہیں ہے. چنانچہ جو 2 phase کمٹ جو پروٹوکول ہے اس کی جو سمپلسٹ فارم ہے وہ یہی ہے کہ ایک ٹرانزیکشن جو ہے وہ تمام لاکس کو ہولڈ کیے رکھتی ہے, اور جب وہ اپنے اختتام پہ پہنچتی ہے ٹرانزیکشن, جب وہ ٹرانزیکشن مکمل ہوتی ہے, اس وقت جو ہے وہ ایٹ دا سیم ٹائم تمام لاکس کو ریلیز کر دیتی ہے. کیونکہ جیسے میں آپ سے کہا کہ پرابلم یہ ہے کہ وہ اگر ایک بھی لاک ریلیز کرے تو اس کے بعد وہ اور لاک اس کو نہیں مل سکتے, اور دوسری بات یہ کہ ہم یہ پہلے سے جج بھی نہیں کر سکتے کہ اس کو کب کتنے لاک اور کس طرح کا لاک چاہیے, تو اس لیے ظاہر یہ پاسبل نہیں ہے. حالانکہ دیکھیے یعنی تھیوریٹیکلی یہ بہت ہیلپ فل ہوگا کہ اگر ہم یہ کہیں کہ ایک ٹرانزیکشن کو جب ایک ڈیٹا آئٹم پہ جو اس نے کام کرنا تھا کر لیا، وہ اس ڈیٹا آئٹم کو ریلیز کر دے. اس اسٹریٹجی کا فائدہ یہ ہوگا کہ آپ کے پاس جو کنکرنسی کا لیول وہ بڑھ جائے گا، کیونکہ جیسے ہی ایک ٹرانزیکشن کو ایک ڈیٹا آئٹم کی ضرورت نہیں ہے وہ اس کو ریلیز کر دے، تو آبویسلی اس کا فائدہ ہے کہ اس کو اس ڈیٹا آئٹم کو باقی ٹرانزیکشن جو وہ استعمال کر لیں گی، اور ظاہر ہے اس سے آپ کا جو کنکرنسی لیول بڑھ جائے گا. لیکن پرابلم یہ ہے کہ اس اسٹریٹجی سے ہمارے جو پرابلمس تھے ایک تو وہ بھی انکاؤنٹر ہو سکتے ہیں، اور دوسری بات یہ ہے کہ بعد میں اگر اس کو کوئی اور لاک چاہیے ٹرانزیکشن کو تو وہ ظاہر ہے کہ اس کو نہیں مل سکتا، کیونکہ اگر آپ ایسا کریں گے تو اس سے بھی آپ کے وہی جو کنکرنسی کنٹرول کے یا جو کنکرنٹ ایکسس کے جو 3 پرابلمز ہیں وہ انکاؤنٹر ہو سکتے ہیں. چنانچہ یعنی جو اس کی سمپلسٹ فارم ہے کنکرنسی کنٹرول کی وہ یہی ہے کہ ایک ٹرانزیکشن جو ہے وہ جتنے اس کو لاک ملتے ہیں وہ گروئنگ فیز میں ملیں گے. اب ظاہر ہے کہ وہ اس دوران اگر وہ یعنی ویٹنگ سٹیٹ میں جا سکتی ہے، مطلب ویٹ سٹیٹ میں جا سکتی ہے گروئنگ فیز کے دوران، ظاہر ہے کہ وہ ایک لاک اپلائی کرتی ہے، اس کو نہیں ملتا تو ظاہر ہے اٹ ول گو ٹو دا ویٹ سٹیٹ، وہ تو ٹھیک ہے. لیکن بہرحال جب وہ ویٹ سٹیٹ اس کی ختم ہوگی اس کو لاک مل جائے گا، لیکن بٹ اسٹل اٹ از ان دا گروئنگ فیز. بٹ ونس ایون جب اس کا وہ ایک بیلنس سٹیٹ آ گئی ہے کہ اس کو اب اور لاکس نہیں چاہیے اور ٹرانزیکشن جسٹ ایکسیکیوٹ کر رہی ہے، تو جب وہ ٹرانزیکشن ختم ہوگی اسی وقت جو ہے وہ تمام لاکس ریلیز ہوں گے. تو یہ سمپلسٹ اسٹریٹجی ہے، لیکن یہ ہے کہ اس چیز کو انشور کرتی ہے کہ کنکرنسی بھی رہے گی اور ایٹ دا سیم ٹائم جو آپ کی کنسسٹنسی ہے ڈیٹا بیس کی وہ بھی ڈسٹرب نہیں ہوگی. تو یہ یعنی جو اسٹریٹجی ہے آپ جو کنکرنسی کنٹرول میں اپلائی کی جاتی ہے. اس میں جو کنکرنسی کنٹرول ہے اس کے اندر ایک اور کانسیپٹ جو کہ استعمال ہوتا ہے اس کو ہم کہتے ہیں سیریلائزیبلٹی. سیریلائزیبلٹی کے بارے میں جو اپنی ڈسکشن کو ہم کنٹینیو کریں گے. آج کے اس لیکچر کا وقت ختم ہوا چاہتا ہے. اب میں آپ سے اجازت چاہوں گا. اللہ حافظ.